When implementing the collaborative filtering approach, Netflix looks for patterns in the data and uses those patterns to determine which recommendations to suggest. We call these patterns dependencies, and they are used to guess ratings. Let's say we're given a set of data representing users and their movie ratings. That would look kind of like this. There's a lot of important information that this data can tell us that you might not be able to spot at the first glance. If you look closely at this data set, you can spot 4 major dependencies. Firstly, we see that the first and third rows are exactly the same. For Netflix, this means that the 2 users have similar taste and they will usually rate movies similarly. Next, we notice that the last 2 columns are the same as well. This can mean that these 2 movies are similar and that people generally give them the same ratings. Then, if we look at the last 3 rows, we see that if we add the first 2 rows together, we get the third row. This means that user D shares interests with both users B and C. Finally, when we average the second and third columns, we get the first one. This means that movie 1 shares concepts with both movies 2 and 3. The method used to achieve collaborative filtering is called matrix factorization. Factorization is when you break down a larger value into its smaller factors. Using this method, we will create factor matrices that represent user preferences and movie ratings based on selected features. These can be any features that are relevant to the movie in question. For example, given this sparse matrix, our goal is to come up with factorized matrices that would multiply together to give us the dataset that we had at first. This can be done by creating a training model that will continuously suggest possible factorizations until the most favorable one has been found. Using an error function that will give the computer a measure of how good each result is, we can implement gradient descent in order to optimize the result. Gradient descent will minimize the error function by iteratively adjusting the parameters in the direction of the negative gradient. Basically, this algorithm searches for the lowest point in the function in order to minimize the error. Once we have the most accurate set of guesses from the training model, whenever Netflix needs to recommend any movie, they can just perform a dot product between the person's preferences and the movie ratings to receive a predicted rating. The benefits of this method are that it saves space by using the factors of the matrix instead of the whole matrix. Once we have the factors, we can remove the combined matrix and use dot products to get the values much quicker. This method is also significantly more accurate as it is based on people's behavior, and it will improve over time, keeping up with the user's tastes.
Created using Powtoon.